My name's Harriet. I hack your AI, so the bad guys can't.
Well, we couldn't talk about artificial intelligence without talking about large language models. I feel like it's hard to believe that ChatGPT was released over a year ago because it feels like it's changed the world. Suddenly, artificial intelligence is being talked about by everyone I know. I mean, my friends and I always used to talk about it, but it wouldn't often be a common discussion among my friend group as well. But it is these days. But what is it we need to know about chatbots like ChatGPT or Google's Bard? And how are they related to large language models? And what about them is vulnerable and risky? That's what we're going to dive into today. Welcome back to my channel. My name's Harriet. I missed the boat in computer hacking, so now I hack AI instead. And I'm here to help you understand how you can secure your AI systems. So text generation has been around for a long time. I certainly remember very bad text message autocompletes. They often predicted an incorrect word, or they would sort of get caught in loops. The modern era of large language models really started with this 2017 paper called Attention is All You Need. Now, I mentioned encoder-decoder architectures in my video on generative AI, but basically they take information about previous data that it was trained on and they put it in an embedding space that is between the encoding of information and then the decoding of information to create something new. In this case, models are ingesting lots of historical text information, they're understanding that text, and then they're producing new text. One of the challenges that language-based models often had was that even if they were given text, it was hard for them to understand what to pay attention to, what kind of context was important for them to base their new text on. And basically this mechanism called the attention mechanism was what this paper proposed, and it changed everything. In basic terms, it helped language models understand what to pay attention to, and once they had a good understanding of context, then they're able to generate really good new information. So what's happening here is we have a large language model, aka we're using a transformer architecture with attention mechanisms, and it's trying to translate this English sentence into French. The attention mechanism allows the model to assign varying degrees of importance to different words in the sentence by calculating attention scores for each word based on its relevance to other words in the sentence, enabling the model to focus on the most informative parts of the input sequence during processing. This is great for just interpreting and understanding text, but also really suits language translation because it basically acts as a map between the source and target language. While sentences may be constructed differently in different languages, words tend to have similar attention patterns. Large language models and their implementations are not necessarily the same thing. So you've definitely heard of ChatGPT, maybe you've given it a go. There are lots of other chatbots that exist as well, like Bard by Google, and they're built on different models. So ChatGPT is based on the GPT family of models. We're now up to GPT-4 as of recording, which means that the foundation model that chatbot is built upon is GPT, but then how it's used can be very different. So creating a chatbot out of a foundation model is very different to all the other applications you might want to use a foundation model for. From an AI security perspective, the important thing to understand about large language models is, at this point, from an AI security perspective, most of the dialogue around large language models and risks associated with them is largely around the use or misuse of large language models. For example, they may have encoded bias in them, which means that the information they provide back includes harmful biases, or they might not have appropriate guardrails on them. So people might be able to ask for inappropriate things, like how to create a very good phishing email or how to build a bomb. These kinds of safeguards are really difficult to maintain though, because asking for a very good phishing email is basically the same thing as asking for a very good marketing email. There is also the risk that somewhere in the design or the development of the model, something went wrong. So for example, models that are trained on very sensitive data, probably data that they shouldn't be trained on, might then give back that same sensitive information. So if you ask for information about certain people and then the chatbot gives back information about their address, PII. The other risk associated with these large language models is that only certain companies can control them. It takes a lot of compute, a lot of hardware to be able to train these models. It took months for OpenAI to train GPT-3, and that model had 175 billion parameters. That's a lot. However, compared to many of the other large language models, this is actually fairly insignificant. Look at these examples. The exact parameter sizes of large language models are often not disclosed, but GPT-4 by OpenAI is reported to have 100 to 1,000 trillion parameters. Llama by Meta might have around 7 trillion, and Falcon 40B and Palm by Google are also rumoured to be in this range. And these numbers are increasing rapidly. We're finding that the more information, the more compute these models have access to, the better they become, and a lot of the time we aren't even sure why. This leads us to the challenge that isn't being talked about so much in the large language model space when it comes to AI security: the potential deception, disruption, and disclosure of information from these models that's different to use and misuse. For example, an adversary could poison the training data that these models are trained on. They can also give them adversarially crafted prompts to give back specific information about the model's interiors. So not so much about trying to build a bomb or craft a phishing email, but more information that gleans to the actual architecture of the model itself. This can then be used to train and launch further attacks, or for IP theft, or for intelligence gathering. Injecting false information into these models as well means that you can deceive them. You can kind of subtly shift the output, what they predict the most appropriate output would be. I have other episodes that discuss in greater detail red teaming and prompting, but these are really important to touch upon now. Red teaming comes from the military originally, but is pretty common in cybersecurity, where your red team is your threat actor team, and they basically mimic what a threat actor would do to try and attack or hack a system. From a defensive perspective, this can be really great because it means that if your organization hires a red team or red teamers to conduct that kind of penetration testing on your systems, it means that you can find vulnerabilities before real adversaries do. In the land of large language models, this is called prompt engineering. So lots of people try and create specific prompts to get information that they possibly shouldn't have. Now, this can be really fun when done in a gamified environment or for research. For example, Gandalf by Lakara is a great prompt engineering game that you can play to see an example of what different adversarial prompts look like and how you could disclose information from a model that you probably shouldn't. However, bad guys can also try and prompt engineer these models so that they can actually get information about how to build a bomb, bypassing safeguards, getting specific information that they shouldn't from these models. There's a lot of people talking about safety in the realm of large language models at the moment, which is great. The only problem that I have is that so many people these days associate AI with large language models when AI is actually so many more use cases, and there are so many more risky situations beyond chatbots. So I think it's great that everyone's talking about it, but that leads to our Harriet hack for the episode, and that is large language models are not the same as AI. There are many more kinds of applications beyond large language models, but it is still good that people are talking about it. It's obviously an area that is really positive because for the first time people can interact directly with artificial intelligence systems, which is really cool. So I'm curious to know your thoughts about this. Comment below if you've ever used ChatGPT or another chatbot and some of the more creative prompts that you've used. If you want to support my channel, please also like and subscribe so you don't miss an episode and help support me in my goal to teach everyone about AI security. That's all for now. I'll see you in the next episode.